All right, so we're ready to begin. I'm Victoria Vesna, Chair of Design Media Arts. Leading this class is also open to the public. It's a graduate class for the first year graduate students to get introduced to our faculty. We're really interested in working with our students very closely and at the same time engaging the larger public. Casey Reas is one of our newest faculty. He was visiting last year, and this year he's officially a faculty and an assistant professor in this department, and I'd like you to applaud that because we're very happy to have him on our faculty. He brings with him something that I always thought and all of our faculty felt is really critical for our students to have, and that's a kind of a deeper understanding of the programming language and what happens behind the aesthetic that emerges in the front. And he's created a language that actually helps creative artists and other people who are creative, who are not necessarily technically inclined or into programming, to delve into the creative aspects of programming. He comes to us from MIT and was actually one of the founding faculty of the Interaction Design Institute in Reas, Italy. And the name of the program that he's developed is called Processing, which he also looks at as an environment, and it's open source, so it's used by many, many people who develop it, create creative projects, including myself. Many pieces I've done recently since I've met Casey use processing. It's created also to teach our students the fundamentals of computing programming with a visual context. And he has exhibited widely already. He's got a very prolific art exhibition career in Ars Electronica, Whitney Museum, Artport in Barcelona, in Tokyo, Brussels, New York, and he's also starting to publish, including an essay called Read Me, Software, Art, and Cultures, Creative Code, etc. The most recent thing that we're working on together is he is editing a special issue for the AI and Society journal that's published by Springer Verlag in the UK on a piece about this kind of software influencing society and how this creative work can influence also our education. So I'm very, very happy to introduce Casey Reas.
Hello? Is the microphone working? I can't hear. Barely? I don't know. Thanks. Okay. Now we're on. So this was asked to be a retrospective talk. So I'm going to be showing a lot of projects today that I never thought I'd be showing in public again. So it's a little uncomfortable. But I'll be putting myself out for you to see what I did before I am as skilled as I am now, and I hope that's fun. So this is just a list of previous places I've been before arriving at UCLA last year. The talk's split into 4 sections: a brief overview of where I've been and how I arrived at the present place. Looking at sketches and explorations, which is essentially my graduate studies at MIT, and then looking at my work over the last 3 years according to a list of themes, and then talking about processing.org, which is the programming language I've been creating for the last 3 years with Ben Fry. So first we have the past. So I studied originally graphic design at the University of Cincinnati. It's a regional school in Ohio, United States, and the curriculum there was very much of a mid-20th century, very based on a Swiss school of graphic design education. A lot of my favorite designers and the people who I read widely while I was there included people like Armin Hoffman, Carl Gerstner, Adrian Frutiger, Walter Eicher, Wolfgang Weingart. Actually all of the faculty except one had either studied in Switzerland or at Yale. And the program at Yale was really heavily tied to the Basel School in Switzerland. So this is the educational environment in which I first studied design. It's really heavily focused on visual communication strategies and systems design, and it talks about perception from the point of view of Gestalt psychology. I went to school at the time of transition between old practices and the contemporary practices. So my first 2 years were all hand-based work. So I was painting letter forms in a black pigment called placa, which is this really amazing matte finished paint, very velveteen. And then doing photostats, and then that gradually transitioned into using the computer as a tool, using programs like Illustrator and Photoshop. For the first time were being taught within the curriculum at the school. And then started using really fancy cutting-edge computers like Centrus 660 and Quadra computers, which were the main Macintosh computers for designers at the time. So that was the beginning. After I graduated, I moved to New York City and went to work for a print company called Design Writing Research, which was led by Abbott Miller and Alan Lupton. And there I was a design assistant working on publications. So typography and publication design was really my first professional passion, and I began by doing that. So we did a lot of magazines and publications for cultural organizations in New York, like the MoMA, the Guggenheim, Architecture Magazine, and this was one of the first things that I was the primary designer on, which is Blind Spot. Is a very excellent fine art photography magazine. So the year now is 1997, and I began working for a company in New York called IO360 Digital Design, which at the time was one of a new kind of design firm starting up in the cities, mainly in New York and San Francisco, that were geared towards building things on CD-ROM and then moving into the internet as a primary space for building things. It was a very experimental company, and we started off doing sort of small animation-based websites and eventually went into building very large corporate distributed publication systems, heavy database driven. So I started off doing a lot of simple animation studies. So one of the first projects that I invested a lot of energy into was called Iogami. And the idea was to present the process of folding origami in an animated way, in a better way than is possible on printed page. So there's a series of 4 models that I spent about 6 months doing cell-by-cell animation on, and then it was all put together inside a program called Future Splash Animator, which was what became Flash after it was bought by Macromedia. So another website I worked on was this website for Wharton Company, which is a creative recruitment firm in New York City. And to my knowledge, this was one of the first websites that was done entirely in Flash. So Flash was originally built as an animation tool for doing small animations within HTML sites. And for this piece of work, I actually did it a different way and did the entire site within Flash, which now is extremely commonplace practice. From there, we started doing projects which were more large in scope. So this is I guess you call it like a weekend guide, or like for the New York Times, called New York Today. And the idea is that it's a calendar of events in New York City. And so at this time, I was very interested in information design. I was reading things like The Semiology of Graphics by Bertin and a lot of the Edward Tufte books, Ben Schneiderman textbooks, etc. And I was really interested in the displaying really dense amounts of data within a unified format. So as happened in the year 1998-99, a lot of the small innovative design companies were purchased by large corporate giants. So our small company, IO360, was bought by a larger company called Rare Medium. This is a diagram of the stock of Rare Medium Company. And I think it's really, really funny to see sort of expressed in a diagram the entire story of the dot-com crash. But this is how it all went. I left the company around this time and went to graduate school then at MIT. So the kinds of sites we were doing at Rare Medium were for companies like J.P. Morgan, companies like Merrill Lynch, and they involved going into a room, like me as a 24-year-old creative director, going into a room with people in very dark suits and white shirts, probably in their mid-40s, and discussing their business with them and trying to find out what kinds of things they need to be communicating through these websites. And so I did that for a while and then moved on. So I went to graduate school at the MIT Media Lab, and there I studied with Professor John Maeda in a group called the Aesthetics and Computation Group. And this is a group of 6 people who spent their graduate education more or less working as a tight-knit group and exploring the idea, really the crossover between traditional design background and computer science, and what kinds of new work can come about from the synthesis of these 2 disciplines. So while I was there, I did a lot of different things. I chose to, in graduate school, learn as much as I could and to really broaden what was possible for me to do in the future. So I did a lot of visual studies. I also did some information design while I was there. And then I also became really interested in the history of kinetic sculpture and robotics. And so my thesis ended up being a group of sculptures. So after MIT, I then moved to Italy, into a region called Piemonte, which is in the northwest, near the city of Turin. This is a picture of the institute where I was working. It was a quite nice setting and a nice environment to work in. This is a view outside the office. This is really typical of this region in Italy. It's a very industrial region, but at the same time it has a lot of natural beauty. So these are the beginning of the Alps that you see in the distance there. The city where the institute is called Ivrea, and Ivrea is where Olivetti was a very dominant company. Olivetti is most known as a typewriter and office equipment manufacturing company from the mid-20th century. And there's a really rich history of design and interface in their products. And so the school was put there as a way of bringing forth this design ethic into the 21st century. It's just a typical classroom photo. These are what the studios look like. One thing that was very interesting about the school is that it wasn't very Italian. It was more or less like an alien spaceship which landed in this part of Italy. There was only really a fraction of the students were Italian. People came from all over Europe, South America, and Asia. So it was a really dynamic culture in the middle of this small provincial part of Italy. The projects there are really human-focused, meaning that it looks at the individual and the person, people's needs and desires, as the starting point for building new technologies. So while I was there, I taught a few classes in wearable computing and wearable technologies. And then I also directed a lot of research projects. So this is a project by Victor Vina, which is more or less a visual programming language for programming these small physical boxes. So we move now more directly towards the sketches and explorations. And essentially this is ranging from before I went to graduate school to after I completed. So these are the first things that I ever programmed. So as I just explained, I'm a designer by training and by background, focusing on visual language, visual systems. And so for me, I've been using the computer as a medium and not just as a tool for the last 5 years. Some really simple exploration into responsiveness. But I think what you can see here is that when I started programming computers, I always approached it through the point of view of my previous background. So that led to some more advanced studies. This piece I'm sorry, just 1 second, I have to stop. This piece is really just a silly visual exploration, and it carries a lot of the ideas from the previous piece forward. And the idea was to develop more or less a sound toy that can be played by manipulating the visual elements on the screen. And also while I was there, I started becoming really interested in electronics and building things with my hands and with hardware. So this is something I'm very, very proud of. It's building a computer which is roughly equivalent to an Apple II from scratch, component by component. Essentially starting with the counters and then adding the memory and then physically adding in the wires for the bus, etc. And so through this computer I recreated some of the early experiments in computer graphics. So before we were using these machines with raster-based screens, all computer graphics were done through oscilloscope or vector-based graphics. So I used the oscilloscope shown here in this diagram and this computer to do some really primitive responsive graphics using two knobs or potentiometers to change the parameter constraints of these images. I also just started building small kinetic objects really just for the sense of play and fun. And I built these series of 3 boxes exploring different ways of interacting with the physical world. So this one had a physical interaction where you actually would touch the box in order to create this movement. It was done all through analog electronics, so no digital memory or program involved at all, just simply some motors and a motor driver chip or motor driver component. The next one involved interacting with an object remotely. So this computer interface actually controlled the movement on this box. The next one was a more removed interaction. So here, it simply responded to the environment and not directly to people in the environment. For example, I had these small solar cells on the side that would store energy as a voltage, and then when the voltage reached a certain level, it would discharge and move these small yellow pieces in a circular movement. So it's a very simple analog way of storing and discharging and having things move in a really asynchronously or stochastic way. These were built really just as quickly as I could in order to explore these different ideas. So more refined projects. This is a piece called Daka Daka that I built with Golan Levin. And the idea here is to look at typing as a percussive action rather than as a symbolic action. So we built these 4 sets of visual alphabets. For example, here, I'm hitting the A key. This is the P key. This is the 6. So treating the keyboard as a spatial system rather than a symbolic system. And it was heavily influenced by, for example, Braille, which is also a positional alphabet. And to make the act of speech, or make the act of typing more like speech, more like a fluid conversation. So there's 4 different layers. And each one treats the data from typing in a slightly different way. This one's the most directly positional. So also we played with ideas of accumulating the keystrokes over time so you can see more or less a history of how you're typing. And this is a photograph of the project installed at the Ars Electronica Center in 2000, where you have one keyboard controlling all 4 visualizations at the same time. I also just became very interested in the history of animation, and particularly abstract and experimental animation. Heavily influenced, for example, by this Herbert Motter photograph of an Alexander Calder mobile in motion. Influenced by some of the early time photography experiments by Julien Marais. Also by futurist painting, like this one by Giacomo Balla. And that led to this piece of software, where you have one object, one piece of simple geometry with a very simple movement. But then on the bottom, there's an interface where you can add multiple instances of this piece of geometry into the space. and with from left to right representing an offset in time. So the concept, or the term here, is called virtual volume, which I think was first coined by Laszlo Moholy-Nagy. And with the height of each one of these lines representing also the transparency of the object. So you can see the change there. Let me just add a few. And then as a general software system, there's then control over the size, and then also the position. For example, you can stretch them out into a line. You can put them into more of a matrix format. And you can also then input different sorts of base geometry and see how the same sort of time-based system applied to different geometry create very different secondary visual effects. So as you can tell by how I was fumbling with that, it's a bit cumbersome to use with a keyboard. So what I did was to move towards an easier way of operating this. And so I built this interface for it, where you have the rings around the outside are controlling the transparency. The ring and the knob in the middle is controlling continuous transition between the different geometries. And then there's controls around the outside for controlling like the position and the speed, etc. So I have a video of this to show. And this was installed in 2001 in Gifu Prefecture in Japan in affiliation with a school there called IEMAS. I'm going to be showing a number of things on DVD, so I just want to take the time now to make sure that it will work for you. So then a theme really became in the work of, I started making this transition between making things which are purely software, purely screen-based, and things which are physical, and trying to have a really good synthesis between the two. So another reason this interface was a very positive addition to this project is that it allowed multiple people to use this software at the same time. So this is Jay Lee, and you can see contrast isn't very good to see, but you can see he's operating the interface at the bottom, and then the resulting image is shown there. So this is a rear projection about 2 meters in diameter. So this physical interface allows for so much more fine control over the software. So this is a totally separate project. A lot of the projects I've worked on in the past have been with large groups, large teams. So this is an information visualization project. And essentially, it is a different way of expressing the data found in Outlook. So Microsoft Outlook is a calendaring software system used by companies for keeping track of all of their appointments and schedules for the entire group. And in this project, this is as it was installed at the Museum of Modern Art in New York for a show called WorkSpheres, which was curated by Paolo Antonelli. There are these 3 stations in front, and each station has a small portable device, and you can input calendar data through these stations and they affect this larger visualization in the back. Let me see. So the part I was really responsible for here was this visualization of the coil or of the entire year. And this is a different way of looking at time other than through a matrix calendar base. So you can go through different months. And then once you're at the month, you can go through different days. And this was right before it was tied into the database. And then the calendar information was shown within this space, where this was the visualization for one person. There's this middle space where you see the lattice work, which was more of an abstract, qualitative visualization of all the data at one time. And then on the right here, you saw the information for everybody for the entire year, where each one of the rows is a day, and each one of the columns is a person. So what you can see are the densities in data, so you can see the volume of appointments or the activity over certain periods of time, different months versus weekends and days. And so this is a very sort of involved project. I think about 30 people worked on it. We used compacts for these small devices, or iPacs for these small devices, etc. Another larger project I worked on was for SIGGRAPH in 2000. This project was called the IM. And the idea is that it's a purely visual-based network where each one of these objects has a camera attached, and they're more or less independent. And the camera information is coming in through the ball at the end, and then redisplayed through the surface of each of these pods. And one of the concepts was to propagate visual information through the system simply through attaching or pointing the cameras in different directions. And this is how everything comes apart. So you can see a little bit more of how everything's built. So then after working on these projects, I spent about 9 months working on this last project for my thesis. And it's a kinetic sculpture, highly inspired by works in robotic sculpture and kinetic sculpture. And I started thinking about interactivity and interacting with physical objects, and as that being a metaphor for the body. So in this piece of sculpture, which you see here, there is sort of the skeleton, which is a frame of steel and aluminum. There's the muscles, which are these series of motors. There's the sensors, or the sensory system, which is made up of these identical sharp near-IR sensors, which can see, detect something in front of them up to about a meter. And then there's the brain, which is a prototyping device called a handyboard. And then the software that runs it, this is a diagram, is built on a library for doing behavior called subsumption architecture. And here you see the sensors on the left, the simple states of the program in the middle, and then the actuators or the motors on the right. Here's a few photographs showing some details. So, like mobiles, this sculpture was very, very carefully counterbalanced, so that it only took a really minimum of force to get it to run. These are some really nice phone cables that I bought in Akihabara. So let me show you what this looks like. This is Asim's brother, Omar. I know, I saw him. So essentially, the goal here was to give a piece of something inanimate, something made of steel and paper and other various electrical materials, a behavior. And so the basic behavior I gave this sculpture was that it was shy but inquisitive. So it would move through if nobody was there, it would move through the environment and sort of open itself out and look for things, But when it detected something in the environment, it became a little bit agitated and started to close off. This was the first time I ever made anything like this, and I built the whole thing entirely with my hands and with mechanical tools. So I learned how to use the lathe and the milling machine and constructed everything from scratch. And as a result, it could have been much better, but it was a really fantastic learning experience. And this piece was never actually properly installed. This is just a demonstration in the lab where I was working at the time. So it was, as all the work I've been showing, they're more or less done in the spirit of exploration and in the spirit of learning. And it's the things I learned through doing them that I now sort of use in my daily practice. So I actually wanted to stop here and to have questions, if people have some. As I said, the lecture's in 3 parts, and we're done with part 1 now.
How much knowledge did you have before you went to MIT? How much programming knowledge did you have before MIT?
I studied really intensely for 1 year before I went. So as much as I could have learned in 1 year. But I learned, the rate at which I learned accelerated when I was there. Anybody else?
Can you talk a little bit more about your experience in working on the large piece for MoMA with 30 people, what your role was and what you thought was good about that experience, or what were the pros and cons at this stage when you were learning?
Yeah. I think it's essential, or for me it was essential to work on both kinds of projects, because if I was strictly only working with myself always, I wouldn't necessarily have as much direct exposure to other potential avenues and other disciplines. So on this project there were essentially 3 teams. There was the team doing the software, the team doing the software on the small hardware devices, the team doing the physical sort of design and presentation you see here, and then also some of the more invisible software, so doing the database part of the software. And the part I was primarily doing was the visualization that you see on the screen in the back, because that's where my area of expertise is. So it was a really wonderful experience to dig into my area of expertise and to push that even further, while at the same time getting a window into other people's disciplines.
Yeah, I have kind of a question about your background in electronics, and especially how you made any sort of a crossover, if you did at this point in your career, into the interface. I mean, where did you, or have you, I mean, when did you start getting into the interface between electronics and hardware? How did that come about? It seems pretty technical.
It's not really technical. I mean, it can be, but I mean, you can work in a way which is more or less, I mean, you can begin with working with it as a sort of in the spirit of play, where you can put things together and become familiar with them that way. But then, of course, to develop mastery, there is a bit of technical, technical bit of it you need to dig into really far.
But did you read hobby journals, or where did you pick up where did you pick up that knowledge? I mean,
when I was at university, actually. I took two really rigorous electronics classes, and they provided a foundation for working on top of. Let me see, I had something to say about that. Oh, I know what I was going to say. I mean, really, studying graphic design, as I showed you, and working really only in a flat world for about 6 years prior to doing some of these early physical work. Everybody I knew was a person, either a painter or someone drawing or someone doing graphic design. And so when I went to MIT, all of a sudden I was surrounded by all of these people working with hardware and building physical interfaces, and it just became very appealing and very interesting. So I just dug into it as far as I could while I was there, because I knew that while I was at university, I had the support in order to learn. If I was doing it on my own outside of that system, it would be much more difficult to get over that initial curve. So I guess now that I'm over that initial curve, I can continue to learn on my own. But what I found with a lot of technical disciplines are that getting over that first initial bit requires sometimes a lot of help. But after you're over that curve, you can do a lot of self-learning after.
Thank you.
Sure.
Hey, what inspired you to move from graphic design into the new media realm?
It was really a gradual progression. It wasn't really a cut. And it really, I guess as a graphic designer, I always felt myself as a system designer. So when I was designing a book, I always thought of it, as a sequential activity where you're going from piece to piece, and each element needs to respond to other elements and grow and change over time. So what I found is that software allowed me to explore my ideas of systems in a far more dynamic way than static media. So I started to, so I went from book design, publication design into web, and then after that I also started realizing the limitations or the sort of constriction or the really rigid structures that are involved in designing things for the web. So that's when I started learning how to working with software directly in a more free manner, because it allowed me to have the most flexibility and the most control over how I wanted things to respond to the environment or to people. So I really see it as very much of a progression, and I guess that's the best answer I have for that. Okay, I'll move on to the next section then. Okay, good. So the next part, which will last about a half hour, is a presentation of my individual or private practice over the last 3 years. It's going to be a combination of speaking, a little bit of reading to you, and also quite a bit of showing. So I'm going to take some time just to show work and give you time to watch it as well as presenting things. So this work's going to be presented in relation to these themes. These are themes I've been thinking about and working with over the last 3 years, sort of underneath all of the more obvious themes in the work. So for me, the idea, or the term open, has 3 meanings, meaning the most obvious meaning that something's open to interpretation. For example, all works are interpreted by the viewer. Openness for me can also mean something can be physically manipulated or physically open. So the actual structure of the piece changes in addition to the interpretation of the piece. And for me, this is the definition this is how I usually define the term interactive. And then third, the word open can just simply mean easy to understand. So something can be comprehended by another person. For process, I have 2 definitions for this word. One meaning the creation of processes, not images or codes. So I make the statement that my work is really about the construction of processes. It's not about the resulting software. It's not about the resulting image. It's really about the construction of processes. And then secondly, the idea of process as the way you go about building something. The word material, for me, I associate with software. So it means that different software languages are like different or analogous to different physical materials. And the word interpretation, for me, means the way a process can be interpreted in multiple ways. So if my work is about developing these processes, what are different ways they can be interpreted or made palpable, made perceivable? So my work for the last few years has been in many different areas. I've been tying together what I've been doing for the last 10 years. So at the moment, I do a lot of work in print, and I explore these processes in print because it enables a certain amount of resolution, or a really intense amount of resolution. I also build animations, so linear animations, and I do this because it gives me control over the choreography, so I can control precisely how things grow and how they evolve in time. I also build installations as well, or physical objects, and I do that because it allows me to explore how these processes relate to a space and environment, or also how they relate to the body. And then lastly, sort of the core of all of my work is software, and I build software for the purpose of allowing people to interact with these processes in order to understand them better. So the piece we were just looking at is a piece of software which was running on the machine. Every time it runs differently. The core of that piece is a book called Vehicles, written by Valentino Breitenberg. And essentially, this book is an abstraction of his research into neuroanatomy. So he spent his life studying the nervous system. And this book is a series of 13 hypothetical vehicles, each relating to his ideas about how nervous systems work. So this is the most simplest vehicle, the first one, where you have a sensor in the front and then a motor in the back, and there's a direct connection between the sensor and the motor, meaning that if it detects a stimulus, meaning that if it's a light sensor and there's a light nearby, it will cause the motor to turn and the vehicle will move forward. So that's sort of the general way these vehicles operate. The next set involves doubling it. So like our bodies are more or less mirrored, you can see that there's three possible connections. There's direct connections between sensor and motor. There's cross connections, which is analogous to the way that, for example, our right eye goes to the left side of the brain. And then there's, of course, mixtures between the two. And this is more or less how our bodies actually work. And then the idea is that with these simple physical abstractions, you can then change the wiring and change either a positive or negative stimulus between the sensor and the motor to get a different behavior. So I developed this piece of software to demonstrate that. And in this piece of software, each one of the vehicles is a dot. And then these lines are created because we're looking at, I think, the 30 most recent positions of each dot. And when there's no stimuli in the environment, you can see that they just move straight forward. If I then introduce a stimulus into the environment, you can see that they modify their behavior because of how they're wired, or because of the really simple program that runs them. In this particular piece, there's a few different kinds of wiring, and each kind of wiring has a different hue, and that's why we see the different colors, the greens and the grays. You can see that then when I add a new stimuli in the environment, that they once again change the behavior to adapt to their environment. So this software, and a lot of the software I've been working on sort of about 3 years ago, deals with the principle of emergence. So you have very simple systems, but when you add a lot of them into the environment together and they interact with one another, these more complex forms emerge from that interaction. Oops. So from this software, I developed a series of prints, and essentially each type of print is a slightly changing the behavior of how these vehicles operate. This is a magnification. And this, for example, is a difference. By slightly modifying the programs of these small vehicles, you can see the alteration in the form which is created. And so these prints were developed very much as an interactive process between myself and the software. They actually were generated the same way you saw me just playing with it a moment ago, where I deposit these dots in the environment, the individual lines respond, and then at individual points I would basically take a still of that environment But then because it moves from screen to print, you have this amazing resolution, which is not possible in screen-based media at the moment. So another sort of fact, or the way the emergent systems work, are that if you multiply the number of elements in the environment, say like times 10, different kinds of phenomena emerge. So this is an extension of that work, where it becomes not about line and becomes more about mass and shape. And then this is a view of how this piece was represented inside a gallery setting, where you see the prints on the wall. Each row is a separate set of vehicles. And then this object we see here was the way that the visitors were able to interact with the software. So you have these brass tokens, and this part of the object that you can move around and set the different control points for the software. And then to look at the same process from a different view, I created these animations. And once again, the animation allows me to have control over the choreography and how it unfolds over time, with more control than the software, where the control there is really given to the person in the gallery.
If you show such an animation, you show it from DVD or still from computer?
I'm still working on that. I'm really unhappy with the quality of DVD, but computer is not fast enough to run these yet. Like, for example, here, this quality is really upsetting for me.
Is there a level of complexity that the mesh introduced that looks to be sort of a lower algorithm?
I just wonder what sort of structures you might have found that develop out of what looks like might be a fairly simple algorithm or logarithm. I don't know.
Well, it's the same algorithm of that first drawing schematic I showed you of the little vehicle with the sensor and the motor.
But have you found any sort of high degree complexity that's developed out of these?
I didn't hear.
Have you found any sort of high-level complexity that has developed out of these, some sort of mutation to high-order complexity?
Not in the direct sense. I'm not, although I've read a lot of scientific papers written on the subject, I'm not pursuing that avenue. So I haven't really been trying or striving to do that, and I haven't found. Light. So the process I use to develop these is I write the software in a relatively short period of time, and then I work with it for many, many months, on and off. And so at that point, I've really forgotten how the software works, and I start working on it more intuitively. And in this particular example, instead of just 3 control points, it's actually done with 8, and that's why some more involved forms can be created through that.
If you are talking print, do you see
Do you see the value, let's say, of the work, the printed work? Do you see it also, let's say, accomplished with just one print, or do you need to have, let's say, a series of prints to
I always do
have
multiples.
it being a work?
I always do multiples, and as a way of showing as it as a system rather than as an object.
Yeah.
And then I also have not yet shown the prints without showing the software at the same time. That's fine. I'll move on in a moment.
Can you ever get the same effect again? Like, have you been able to recreate the same thing that after you've taken the screenshot of it? Or is it sort of like
Yeah, it's purely
once in a
deterministic.
lifetime type of thing?
Yeah, you just put in the same numbers and you get the same result.
Oh, okay.
But I don't work with it that way, but it would work like that.
All right.
Yeah. Okay, and then once again, we were looking at...
Can you talk about how the dynamic changes between...
So just 1 second, Davey.
Yeah.
This is what we were looking at before, but this is essentially sort of the same process as it's expressed as a piece of software rather than as a piece of animation. Because sort of the media of linear animation is different from the media of live software, they need to express themselves differently in order to run. Yep. Davey?
I thought it was interesting that you show the process of how the art's being created within a gallery setting. When you're showing the screen and stuff with the prints. Can you talk about how the sort of dynamic within the gallery changes if you had like just the prints or just the software?
I don't really have a good answer for that. I mean, it depends on the gallery, actually. I mean, some galleries people go to because they know a certain kind of work is being presented. So having work where you can touch and you can move things and play with them actually puts people off. And in other galleries, it's the reason people go. So the gallery where I was showing this work, half the people are really, really interested in the static images on the wall, and half are totally ignore them and just work with the software. So I think it's strong to have both in order to compare and contrast the two. Thanks. Okay, so I move on. Okay, so I made the statement earlier that this work is really about the process and not about the image or the result or the sort of the way the image looks in the end. So then I think for me the question comes up, what's the appropriate representation for this process? And to date I've chosen a really minimal visual style in the sense that I'm only using lines to represent the process with the idea that it's the easiest way of directly communicating the core of the process through keeping the visuals extremely minimal, so that it's more of an accurate representation of what's happening. But of course, that's not entirely true. So, for example, this is another representation, which for me is not an interesting representation, but it is an equivalent representation of the process, which is the code in which it's built on. I'm not sure. And then, for example, this is another representation of the process, which is equally valid, but not to my taste. And then here you can see each of the vehicles actually operating and moving, and you can also see their sensors. But it's really exactly what we were just looking at, but just from a different scale. Here's something in between, which is it's what we were just looking at, but where the visual information accumulates on the screen. And then lastly, it can also be represented as the data. And these are the actual numbers from the previous piece we were looking at, shown as numbers and not as positions and colors, for example. So I think it's rather a rhetorical question, but it's something I ask myself a lot, and I think it's important for my work, is if the work is a process, how do I represent that? Okay, so now I'm actually going to discuss process directly in a different sense, in the way in which the work evolves over time, from idea to finished piece. So for the last 3 years, I've been developing a programming language called Processing with Ben Fry. It's a software language and environment for visual arts and design. It's built really meant to be a software sketchbook as one of its reasons for existence. The idea is to get ideas out of your head and into the world as quickly as possible, which is something that is traditionally very tedious to do in software. So for example, if I type in the size of the screen, and then if I draw a line diagonally, and then hit run, you can see that the code is then transformed into image directly. So this is fundamentally how processing works. And I'm going to show you a few sketches that I've done, working towards a larger idea. So this is the first piece I built. It's a small chunk of code, and it has the effect of when you move one circle on top of another, they always move apart because they don't want to share the same space. It's really that simple. And then so there's many ways in which this could progress. And the next step I chose to animate the piece so that you can see that they're always moving, but they're never overlapping because when they touch, they always change the direction. So now you have an automatic system. So the next step in the evolution was to visualize that a little bit better so I could see what was actually happening in the program. So here you can see the direction of each circle is represented by the yellow dot. And you can see that when they're touching another, they change the direction. When they're touching two at the same time, they change the direction twice as fast. And when they are not touching another, they just continue going along the same vector, the same direction. The next step was to remove some of the information. So I removed the circumference of each circle, and now we're just seeing the directional dot, and I've also added something. So when they touch, when they kiss each other, these lines are being added from the center of each circle. And then this version, I removed everything except those lines that occur when they touch. And small lines are white and long lines are black. So there's a certain threshold in which they switch their color. And then also I'm accumulating information into the screen so that it's not updating the frame not clearing the frame each time, but it's adding the information. And then so the final version that I did in processing, we see here. And so in this version, there's 3 separate colors, each for a different length of the line. So like if a large circle touches a large circle, it's going to be a long line, so it's assigned a certain color. If a small circle touches a small circle, a different color will be assigned. And then this is just another visualization of the same data. And then there's different starting points you can begin from. And once again, this is the same process, visualized in a different way. So this is about as far as I could take this idea within processing environment. As I said, it's meant to be a sketching and learning environment. So what I did was move this process over to a different kind of coding. And actually something I need to say about what we were just looking at, which I think is very important. So the original process was written, and then each of those subsequent steps after that was really only changing maybe about 5 or 10 lines of programming code. So out of maybe like 200 lines of code, only about 10 lines were being changed. So at that point, you really stop acting like an engineer or a programmer, and you begin acting like an artist or a designer, in my opinion. Okay, so this is the same software then taken over into a different language environment. So this was written in C++ using OpenGL for the graphics. So that's really without any change. And then I worked with it for a while longer, and then this was the final piece as was exhibited.
Are you bleaching out elements while going after a while?
Happens in a moment. So it accumulates until it reaches a certain saturation, and then it actually refreshes itself, but in what I hope to be a really fluid way. I'm actually not very happy with that transition, but that's how it ended up for that piece. Yep. So this is the other alternative visualization of the piece. So really the difference between, I guess, what I was showing before, which is what I showed the last two, is a difference of resolution, meaning that there's an increased resolution in dimension and also a resolution in time, meaning more visual information being presented. Okay. And then another variant on this, which I'm a bit obsessive compulsive by nature, and so when I get working on a piece of software, sometimes I just keep working on it way past when I should have stopped. But sometimes nice things come out of that. This is a different variation where essentially I created this really rigid way in which they appear on the screen. They always come from the center and then move towards the outside as they get pushed away by the other circles. So this is essentially the same software we've been looking at now for about the last 10 minutes. But by giving it a different starting point, some very different kinds of form emerge. And then this was a basis for an exhibition at the Tele Gallery. And as you may or may not know, the Tele Gallery is a place where a lot of graduate students in this program and sometimes other media artists show their work. It's located in Chongqing Road in Chinatown. So that was showing sort of what it's like in a space with people. And this close-up shows more of what the images were like being projected on each disc. So there are 18 different discs in the space, each one with a different variant on this image being presented. For me, it's really difficult to present an installation on a screen like this because you really get not much of an idea of what the piece is actually about. It's really about a very sort of a tension between organic and synthetic and moving through the space and seeing how it unfolds over time. Okay, and then I couldn't resist one more opportunity to use this process, which I really, really loved. And so I modified it one more time, and this time making it very interactive. So in this sense, it became a piece of drawing software. And it was written as a piece of drawing software meant to be played live with music from Steve Reich's Music for 18 Musicians. Which sounds like this. So it's a very delicate percussive piece where the voices and the clarinet have these melodic tones on top of the repetitive percussion noises. And then these images show how it unfolded over time. So I just quickly want to show that software. And this software, once again, the physical way you interact with the software is extremely important. So this software was originally meant to be used with a pen tablet on a very large surface. So right now I'm using my finger on the small trackpad, and it has a really different effect than the way that my hand can work in an unrestricted way. So right now you're losing a lot of the gestural and a lot of the nuance that was built into this piece of software. So there's different variations on the software for different sections of the music. And the information you see on the bottom of these two lines, there's actually like a scratch area for me as the performer while the concert is happening. And so I was drawing live sort of as a visual accompaniment to the musicians, mostly working off the sounds of the clarinets and the voices. And the projection was of that aspect ratio where you see the lines. Okay, so now I'm going to talk about openness, but the kind of openness meaning accessible, and the fact that different programming languages, for me, are analogous to different materials. This is a nice quote from Larry Kuba, who's a pioneer in abstract animation. Each of my films has been made on a different system using a different programming language. A programming language gives you the power to express some ideas while limiting your ability to express others. So I recently did this project, which was commissioned by Christiane Paul for the Whitney Museum of Art's Artport, which is an online version of the online section of the museum. And I used it as an opportunity to explore a different kind of programming, where it's a throwback, or it's in reference to the work of Saul LeWitt, which he began in the mid-1960s for wall drawings, where he would write a text description of structure, and then it would be executed by a draftsman within the wall of the gallery. And these are essentially programs where instead of being executed by a machine, they're executed by a person. And one thing I thought was very amazing about these programs are that they were written in English. And writing a program in English is very interesting for two reasons. One, it gives the audience an idea into what the program is about. And secondly, it allows for ambiguity. So when you're writing programs for machines or for computers, writing software, you have to be very, very precise and very controlled in what you say. And someone coming from a background which is non-technical, being forced to be that precise all the time about visual decisions. You have an idea visual in your head, you have to translate it into this really precise syntax, which then becomes visual again, is very non-intuitive. So I explore the idea of programming software in English for this project. So this is the program. A surface filled with 100 medium to small size circles. Each circle has a different size and direction, but moves at the same slow rate. Display the instantaneous intersections of the circles, and B, the aggregate intersections of the circles. So this, for example, is a static image taken from a piece of software executing part B of that code. So this is the aggregate intersections of the circles. So I'll show you more examples of this. So on this page, you can see the structure is here, the English program. Here we have a visualization of part A, the instantaneous intersections of the circles. And this is as programmed by myself. And here we have part B, the aggregate intersections of the circles. This one takes a little while to unfold. And then so what I did in the project was to commission 3 artists to then take my English program and then interpret that as software. So they all did this without any instruction from me or without any communication between themselves. And for me, it was very interesting to see the similarities and differences between how they interpreted my program. This one's by Jared Tarbell. And this one's the most similar to my original implementation. This one's the most similar to my original implementation. This one's by Robert Hodgen. This one's by my friend William. So I don't really have any conclusion to draw from this, but I think you can see for yourself the really vast differences between how this was interpreted. For me, that's very interesting. It becomes not just my project, but it becomes a collaboration between myself and these other individuals. Another part of the project was to take the same structure, essentially the same software process, and implement that in different materials. So once again, this is the processing version, or it's the Java version of the software. And here we see the Flash version. And what this reveals is that Flash environment is actually not even capable of doing this because you can't accumulate information into the frame buffer. You have to refresh every frame. And then the other thing you see here is the decrease in frame rate. So we're only getting about 4 frames a second. And that's sort of a property of the material, which is Flash. And then lastly, we have a version done in C++, which one of the properties of this is that it cannot run over the internet. So people have to download it and then run it on their machine. So I'll let this one run for about 30 seconds. So to give you an idea of what's happening there, I think this one visualizes it best. When the circles intersect, you can see those lines being drawn from the points of intersection, and it's those lines we were just looking at. But I don't know, for me this was, I knew this would happen, but I didn't know it would happen to this extent in this project. So I didn't know there would be as large of differences between the different software materials and between the interpretations by the different artists. So I guess what I learned is that in order to, I guess, have a more direct relationship between my intent and the way these structures are interpreted by other people, I just need to be a lot more explicit in how the program is written. But of course, I don't want to then be as explicit as if I were writing it in code itself. Okay? And then I took the same structure once again and interpreted it in a different way. So here, once again, we're looking at the same process, but visualized in a very different manner. And this one's actually a drawing software, so I can, with the cursor, deposit the individual circles on the screen, which then after I stop drawing them, they continue to interact with each other. And here, instead of drawing a line between the two intersections, I'm simply drawing a circle at each point of intersection. And the color of the circle is based on the size. Okay. Okay, so that's the end of part 2. If people have questions right now, I'd be happy. If not, we'll carry on to part 3.
Any questions? I think you have everyone mesmerized.
I request one question to break my tedium. Miriam, could you turn the lights on real quick? Actually, there was a student question back.
I was curious if, to your knowledge, anyone has used your visualizations to explain the processes and concepts for another purpose, like for another subject, or?
No, I usually leave it as they are. And actually, I should also say that what I'm showing you right now is something I usually don't show anybody. It's because we're all private UCLA family. I'm sort of like opening up the files, miscellaneous files on my hard drive. But I'm sorry, Christian, that was rude of me.
But you realize that this is streamed and archived, so...
That's all fine.
It's a question what has less to do with your work. What with the Whitney Museum, since when are they doing this digital gallery?
I think they've had that online for at least 5 years.
2001.
Oh, really? Just 2?
I think
Okay.
2001. That's on the... Are you planning to talk more about processing and the collaborative process next, or so that would be preempting? Okay.
Yeah. Okay.
Go ahead.
Okay, so part 3 is talking about processing. So I've been building processing for the last 3 years with Ben Fry. I started building it when I was living in Italy, and he was a PhD student at the MIT Media Lab. And now I'm here, and he's graduated, and the project is continuing on. We recently, we just released a new version last night, so the project's alive and well, and we continue to develop it. I think very excitingly, it's also being used at UCLA this year, and I'm happy to see a number of my students and Daniel's students here for this introduction. So processing is a programming language and environment built for the electronic arts and visual design communities. It's created to teach fundamentals of computer programming within a visual context and to be used as a software sketchbook. Processing began at the MIT Media Lab. It extends ideas explored in the Aesthetics and Computation group led by John Maeda. So this is a timeline and shows the influences of different environments which informed the development of processing. So there are a few fundamental statements which underlie the entire programming language and the community surrounding it. So first we have, software is a unique medium with unique qualities. Concepts may be expressed in this media which are not possible to express in other media. Simply meaning that software is unique. It's not film, it's not painting. It requires its own terminology and its own discourse. Each programming language is analogous to a different material, each with its own properties. In the physical world, if you set to build some sort of object, you may choose oak, you may choose aluminum. The same is true in software. Some kinds of programming ideas or concepts lead themselves to one language more than another. And related to that, every programming language enables different ways of thinking. It's important to be able to sketch with software. We're very used to sketching, for example, with pens and paper. We're used to sketching with cardboard. There are not a lot of programming environments or a lot of ways of sketching software. So processing is meant to be an environment for doing that. Educational languages should enable future learning rather than constraining it. The idea meaning that the first programming language a person is introduced to determines the way they think about software, either as something which is open for exploration or something which is very finite and closed for specific tasks. And there's a misconception that programming is only for a specific kind of person. I think most of the programming languages in existence today were written for engineers, by engineers, and not until more artists and designers begin writing their own languages will we see the kinds of programming languages emerge that we need for doing the kinds of things that we'd like to do, for exploring concepts essential to our disciplines. I mean, essentially, computers are calculating machines built for accuracy, and oftentimes the goal is not accuracy, it's something else. So there are really two parts for processing. There is the programming environment, which we see here. It's the window with the text editor and the menu bars. And there's also the language itself, which is the syntax that you put into the text window. So I'm just going to show you a few really quick examples. So the typical way of learning computer programming is the first program is always hello world. In processing, the idea is to making visuals as easy to do as writing text. So here you can see we're printing hello world to the text area at the bottom and also drawing a line at the same time. In a lot of other programming environments, it takes maybe 30 lines of code to just get a line on the screen. So that's what separates processing from a lot of other environments. Of course, you can draw things which aren't geometric primitives. This example shows how you can draw based on individual vertex points. And this is based on the way OpenGL works. Computational color or programmatic color is another topic in itself. This shows how you can change the color space and the range, and also how you can set the color of individual pixels. This is about the simplest program you can write for making something move. Here we see an additional structure where we have a setup, which happens once when the program begins, and then a loop where the code inside is executed from top to bottom and then back up to the top continually. And this example shows how you can have a simple response from an external input to the computer, such as a mouse. So here, we're moving left to right changes the position of the bar, and clicking the mouse changes the value. You can see here the variable mouse x, which just always contains the horizontal position of the mouse. So processing is designed for two groups of people. People who want to learn computer programming, people who already know how to program, but want a better environment for sketching and prototyping. For the people who are learning, it's a really good base for future accomplishment. The way the language is designed, it leads very easily into doing different kinds of programming in the future. For example, in the work I've shown today, I've shown work that was done in ActionScript, written in Java, written with microcontrollers. That's what you use for building physical objects and controlling them, and also OpenGL, which is an advanced graphics library. So the ideas developed through learning processing continue on to each of these different programming contexts. It's also good for beginners because there are immediate visual results. There's three modes of programming, meaning there's three layers of complexity that you can begin writing simple programs within 5 minutes of looking at the software, but then there's really no ceiling, which is a problem with a lot of the programming environments built for the visual arts communities, meaning that you can keep scaling the complexity of your programs without really hitting a limit. it's really easy to get some of the core ideas of software across through processing in a very clear and direct manner. I can show an example of this. I'll just go through some of the basic elements of software. So this is iteration, and what we're going to see in these examples are the code on the right and then the direct expression of the code in graphic on the left. So if I were to cut and paste one of these into processing and run, this would be the result. Recursion, arrays, random, basic motion, conditional, so being able to detect the position of something, Brownian movement, being able to read the clock of the computer. The next three are related to, simply related to doing graphics. So this is translation, rotation. Sorry, the first one I was scaling. This one's translation. Here we have simple responding to the mouse, up and down. Being able to calculate simple values. For example, this is distance. So you can see the distance of the cursor from each rectangle determines its size. Also embedding loops. A simple program for storing information and representing it. So here I'm storing mouse values and then showing them on the screen all at the same time, cycling through an array. It's a simple program for drawing where it takes into effect the speed in which the cursor is using for setting the size of the objects. This is specifically for 3D graphics. It's pushing and popping matrices. Once again, color. So this is looking at the brightness and isolation. Loading in images, sequential images, and typography. So this is just meant to be a really fast introduction to a few of the things that can be taught simply within processing. It's also good for people who already know how to program because it has a familiar syntax, concise programming structures, meaning that if you were to write the same program in another language, it might be twice as long sometimes. There's libraries for doing simple tasks specifically for the kinds of things you might want to do, like attaching a camera or generating sound. There's many examples available, and there's also a really large community of people using the software that to this point have been very open in helping. So for me, these are really critical aspects of the software, that it's free software in the sense that it doesn't cost any money. In the future, it will be free software in the sense that it will be entirely open source for people to download and look at. It's currently free to download without cost. It's available for as many platforms as are viable, so as many people have access to it as is possible. As I said, it's almost open source. We're in the final paperwork of that. And then really importantly, we promote what I call the view source sort of methodology, or not methodology, but the view source idea that when people are posting their work on the web using processing, they make their programs available for people to see. Let me show you an example of that. So for example, I have this very simple program which I've written. I can hit export, and then I have an HTML file already built. So this is a file for the web. I can double click on it and open the web browser, and then now I can put this on the server and the work is viewable online. So this is one way that the project is really propagated and people have been sharing their information. And then in addition, if I click the source code, it opens up a window which shows the code, which is that program. So a lot of people have been very good about sharing their labor with other people. So I have some more advanced examples now. So once again, these aren't finished projects using processing. They're simply more or less demos of what it can do. That's the demo of drawing directly to the frame buffer. Here's showing the ability to draw in 3D. Here we have the ability for simple but effective interactive and animation. This is a piece by Golden Levin where you make a gesture and then the gesture continues after you stop drawing. The ability to read in images and then treat them as a data set. So this is representing the color from one image in a different way. Once again, a simple demonstration of 3D possibilities. It's very simple to create simulations. So, for example, here we have a simple spring simulator, where I can create. It is Soda, actually. It's Soda without the rest of the interface. It's done by the person who wrote Soda. And typography. So getting type off the flat page and into space and motion. And then another really important thing about processing is that it provides a really strong bridge between two communities which historically don't communicate at all, but which have a lot to add to each other. This is an example of a flocking algorithm written by Craig Reynolds, who is a really important researcher in the artificial life field. And because processing is similar enough in the way the language is written to a lot of the languages that people who are actually researchers in fields like artificial life, that it's very simple to take their ideas and to translate them into processing. And it's really simultaneously an environment where people who are visually skilled have advantage because they're able to control the visual parameters for communication, and also people who are very good programmers have an advantage. So it's really an environment where both groups can come and neither one has an advantage over the other. And 15 years of research into computer graphics and interaction can be immediately ported into processing, while some other languages like Flash or Director's Lingo, because the languages are so different from the way the researchers work, it's not really possible to bridge that gap at all. Okay, so I have a few more advanced examples to show. And these are sketches written by very talented people using processing as a software sketchbook. So this is another one by Ed Burton, who is the author of Soda Constructor. And this is a new thing he's been developing, and it's being supported by the British government for introducing a new way of drawing into public school systems. The idea here is that you can doodle. Whoops. And the idea is that the objects have an awareness of their position. And you can also attach to other objects. And then you can move them. You can also train them. So you can give it a basic gesture, and then release, and then that gesture continues. So it's a very different way of thinking about working with animation. And then you can change, for example, the gravity of the environment. You can change the friction. And you can also change the stiffness. Okay, so you can also, of course, save drawings and then replay them back later. So a number of these drawings were done by a 13-year-old student. I'm not sure which ones are which, actually. And of course, after the drawing, you can continue to draw on them or continue to manipulate them. This one's called the collector. And so I think it also has a lot of potential for being a storytelling media. And so as I said, this is just a sort of a sketch done in processing, and now they're pursuing the development along more established routes. The person who created this, Ed, is a very, very busy person. He owns a company, and actually he said that he wouldn't necessarily be able to build this project without the sort of how fast you can do it within processing. Okay, it's a piece by Amit Guitar, and it's a sound sculpture piece. The idea is that it's like a music box where you can draw lines into the space. And then when they come back around, they're played. So it's a three-dimensional wire sculpture, which can be treated as a musical score. So if I wrote something you've already done, you don't have control over And then this is an example of information visualization by Ben Fry. And this is one of them. He did his PhD research on visualizing the human genome. The idea is that you have these 5 representations at the top. These are the ways that scientists are looking at the genome data, and they're actually all just sort of different views onto the same data. So he built this interface as a way of showing how these different visualizations relate to one another. Because, for example, some scientists, they'll swear by this visualization, but they'll totally discount this visualization, saying it's not accurate. That's really a crude way of explaining it, and might not be entirely correct, but it's the general idea. And so in this visualization, he allows you to cycle between the different ways things are being visualized. You see it from different sides. You can see it with an even spacing or a distributed spacing. At the bottom, you have these parameters, and these are the different blocks, or the way this genome data is often looked at. You can see by changing the parameter set, how the blocks are become restructured. So it really easily exposes how some of the assumptions that you make in structuring the data affects the way it's presented. To really explain this would require about 10 minutes, and I need to look in my sketchbook, so I'm not going to do that right now. So, I want to talk really briefly about the community surrounding processing. So it's used very much internationally, mostly in Europe and the United States, and also in Japan and Korea. And for me, what's very exciting is that it's not just used in universities, it's also being used by a lot of individuals who are using it as a tool for self-learning. This is an example of a workshop I gave in Basel about 3 years ago. This is one from L'Atelier in Paris from about 3 years ago. Also, many other people are giving workshops. This is one from Bilgi University in Istanbul by Reed Cram. It's been taught at UL in the architecture program and the graduate program there. This is a website from the UDK in Berlin. It's actually replaced Flash there, and they're teaching with processing. Joachim's Hauser School, University of the Arts. I think Ralph Amer was the professor for this class. And then also, as I said, many people are building work in processing and posting it online as a way of distributing their work. So this is David Lowe, who is a former student of mine in Reas. Mikhail Kozer, who is a student at Royal College of Art. Glenn Murphy, who Victoria knows very well, has done some work on the Nano project. The website is a hub for resources and communication. Here's a piece by Krister, is he here? Aha. So the website has a lot of different sections, and it's really a place for communicating about the project and for people to share their ideas and work together. The exhibition is curated by myself, and there's also a section where people can post any project they want. So it's a mixture between curation and contribution from the community. There's a complete set of examples and a complete reference of the language. One of the ideas of the language is to make it make a balance between power and size, so it's as small as it can be. And every time we add a feature, we debate about it for a long time. Another example of a reference, it's been written intentionally for people who don't have a background in programming. Most computer science books are actually written for people who already know how to program. It's also been translated into many languages. For example, it's been translated into Japanese, Korean, Indonesian, Chinese, simplified and traditional, French, Spanish, Italian, and Turkish. And then there's also other languages being worked on. Someone actually was interested in translating into Farsi last week. And the discourse board is just a really simple bulletin board, but it's been really effective for doing what it should do. So we have people sharing the work, people asking questions. We have a dedicated people's community who actually answer back and help people through things. So it's a really friendly place for beginners to be. So technically, it's written in Java and has a custom graphics library inspired by PostScript and OpenGL. Meaning that people who are familiar with Illustrator will understand how it works. People who are familiar with OpenGL, computer graphics, will understand how it works. There's more and more libraries being written for it, which are contributed by the community. So for example, there's a few libraries for reading in camera data, libraries for doing sound synthesis and playback, libraries for doing networking between machines, a number of data communication protocol libraries, libraries for doing vector export, so you can actually write programs and processing and then export them to Illustrator files or PostScript files. You can communicate with other environments like SuperColor and MaxMSP, et cetera, et cetera. So it's really growing very quickly and becoming a very powerful tool. So this figure is about a month old, but since September 2003, over 16,000 people have requested the software. We really have no idea how many people are using it because it's being taught at universities and shared over file sharing applications, et cetera. And that is the end. So thank you.
So we do have a few minutes for last questions. Anyone?
What are the specific limitations of the language that are keeping it strictly as a sketchbook tool and not like a production tool for a finished piece?
It actually can be used as a production tool, and a lot of people are using it as a production tool for doing installations, for doing kiosks, and also for doing web work. I just try and refer to it as a sketchbook.
You were stressing how you, in printed media, the resolution is really important to you. If you could get a higher resolution for interactive media, would you just continue doing prints, or would you continue to?
Yeah, I probably would. Because, I mean, for me, the motion is extremely important. And if there were resolutions as high as the physical world, I might. But actually, might not either, because I'm really interested in drawing as well, and you use a lot of the emotion and activity if it's on screen. So, but I definitely, I think one thing that's really important point is that when we look back 30 years ago and look at the machines people were using and we snicker to ourselves and laugh, we just have to realize that the machines we're using now is sort of the same thing, and that to use computers in such a way where you're aware of the limitations they're imposing and to try and develop ideas outside of the technology. Okay.